All right, for this video, we're going to be using our knowledge about confidence intervals to help find sample size. And so what we're going to do is we're also going to look at, this is just review of the confidence interval for P. When we talk about the bound on the error, we're talking about the margin of error formula. And so the margin of error, or the bound, is going to be this part of that formula for the confidence interval. It's your critical Z times your standard error of your estimate, okay? And so another name for it is the margin of error. Okay, and so our standard error is this value right here for proportions, right? It's going to be P times 1 minus P all over N, and then taking the square root of that. So we often see hats because we're working with estimates. Okay, so that's our margin of error. And so when we see a confidence interval like this, a lower bound and an upper bound, the bound is going to be half of this distance. So to find that, we take our 0.65 upper bound, subtract the lower bound, and divide by 2. That's going to give us 0.10 over 2, or 0.05. And if you want, you can always do that on a calculator. Remember, when you use your calculator, you're going to want to make sure that if you just type that in and then do divide by 2, you're not going to get the right answer. So make sure to hit enter first and then divide by 2. Or put that in parentheses and then divide by 2. So we get 0.05 here. So our margin of error is 5% basically. So here, from 0.73 to 0.71, it looks like only 2% difference, so I'm going to assume it's going to be 0.1, but let me show you again how to put that in your calculator. I'll use the parentheses this time. We'll do the upper bound minus the lower bound, and then we'll divide by 2, and we should get 1%, or 0.01. So 0.01 here, all right? 0.73 minus 0.71 divided by 2. Okay. Find the sample size needed. Okay, so you had one of these in your homework, and probably that stumped you a little bit unless you read the chapter. Blah, blah, blah. Find the correct percentage of people who approve of the president's job performance, assuming you want a 3% margin of error. So we need to do this. Okay, so we need the confidence level, and we need the actual margin of error. And so we have a couple different ways that we can solve. Since the confidence interval formula is this, we can just work backwards. So we are going to find that bound as the critical Z. Notice we're ignoring the plus and minus. We're just finding the bound here. So we'll set our bound equal to the margin of error that we want, 3%. We change that to a decimal. We're using our critical Z that's affiliated with 95% confidence interval. So that's that 1.96. And then notice if we don't, we haven't done the, we haven't chosen the sample yet. We haven't calculated anything. We're trying to figure out how many people do we ask. So we have no idea what P hat's going to be. So we just assume 0.5. That's a midpoint. Okay, so that numerator is pretty much always going to be 0.5 times 0.5. And then notice here's our N. That's what we're going to be solving for. So we take our 0.03, we divide by 1.96, we get this. We like a lot of extra decimal points here. You can just leave that in your formula if you want to. I mean, in your calculator, you don't even have to round it, but leave a lot of extra decimal places. And so when we divide here, we get this equals 0.5 times 0.5, which is 0.25 here in the numerator, still dividing by N. We want to square both sides here, okay? To get rid of that radical, that's going to leave this 0.25 over N here equals this number squared is this. And then to isolate N, we need to multiply both sides of the equation by N. Right? And that's going to give us 0.025. But now to isolate N, we divide both sides by this. And you take this, divide that by the same amount. I know these are some awesome advanced algebra skills that I'm sure you all remember. But we do find out that N equals this many people plus a little bit more. So it's 1,067 people. Part of a person? No, round up to the next whole person, okay? So this isn't your typical rounding. We need at least this so we can go up to the next person. Always round up, okay? Always rounding up. And always use this because we just don't know what the actual proportion is going to be, but we use this because it gives us the biggest possible sample size because we don't want to be too small. What happens is when the actual point estimate, once you collect your data, if you find that the point estimate is more than this or less than this, it's still going to it's going to still give you a better result. Your margin of error will probably be less. So that's good. You want a 3% margin of error at a maximum. You don't want anything more than that. So you want to choose a value of P that when you put that in the formula, based on the math and the numbers, it's going to generate the largest possible sample size. And then remember, always round up. Okay, now another way you could do this is you could rearrange this formula isolating n. And if you rearrange the formula isolating n, you're going to use this. Okay, so that's basically everything that was just done here, but in reverse order. So you can put in the bound, 0.03. You can put in your critical z, 1.96, and use those same p-values. And so when you do that, you're going to get the same result, always rounding up. And then, look, this is from Mr. Simon. I told you these notes came from Mr. Simon. The formula is so easy. I'm definitely going to do it that way. Great. But one, it's not on the formula sheet. And two, there's a second sample size formula coming, and it's not on the formula sheet either. So that means you're going to have to memorize some things or just do this type of math here. Okay. He says he's old and can't remember stuff, so he used option 1 personally. Well, that's cute. He's not that old. All right. Now, what else have we got here? Okay, next page. 10 super duper facts about P confidence intervals. I'm going to tell you about that next time.